Hey, all you Gretas and Chatezcats out there. We are going to do Unit 1, Section 3 notes. This is Biogeochemical cycles. So you've had this before in biology class, hopefully. And if you took environmental science, you had it there too. But we're going to review this again because this is definitely stuff you're going to need to know. And this is stuff that will show up over the course of the year in other topics as well. So let's start. We are starting on page, this does not have a page. Biogeochemical cycle section. The elements and compounds that make up nutrients move continually through the air, water, soil, rock, and living organisms, and in ecosystems and in the biosphere in cycles called biogeochemical cycles. So if you break down the word, bio means life, geo refers to rocks, and chemicals refers to chemicals. So it's all of these different elements and compounds are making up, they're going from us to the environment, and from the environment back into us, and then other things. So we're just moving all over the place. So this is what we're going to talk about. So we're going to start with the carbon cycle. So here we have different aspects of the carbon cycle. So carbon is the element of life. We kind of need it to make up most of us. The concentration of carbon in living matter is about 18%, which is 100 times greater than that in Earth. So there's a lot of it in us. For life to continue, therefore, carbon needs to be recycled. You can't just let it end in living matter. So, carbon in the abiotic or non-living environment. We have carbon dioxide in the atmosphere. You're breathing it out right now. And then we also have CO2 dissolved in the water, which will come into play in multiple units in the future. So there is that. Carbon in the abiotic environment. Remember, these are things that are living or things that were living. So we have calcium carbonate in rocks. So things like limestone and coral are made from carbon, calcium carbonate. And then we also have deposits of, abiotic is still non-living, deposits of coal, petroleum, and natural gas from fossilized organisms. Once you become fossilized, you're no longer living, you're a rock. And dead organic matter or humus. Some people say humus, I say humus. So you have all these dead things or things that were not alive. Carbon enters the biotic world, a living world, through two processes. We have photosynthesis. So things like plants, algae, cyanobacteria are going to take carbon dioxide and water and turn it into sugar and oxygen. And there you go, using the energy from the sun. Chemosynthesis, archaebacteria does, and they actually take various chemicals like sulfur and can actually turn that into different things. So you should know this process for the most part. So we're taking things in. Now we don't photosynthesize, but we do eat the plants that do photosynthesize. So that's how we get our carbon. Carbon returns to the atmosphere and the water by cellular respiration, which is the opposite of photosynthesis. You can burn things. So when you see a log that is burning, that is a lot of carbon dioxide that is given off, and then the log itself is being broken down. So you have the heat energy being given off, and then it's breaking down into the original carbon, which is either going to go back into the soil or up into the air. And then you can have decaying as well. And there's a really pretty picture of something decaying there. If oxygen is present, it will produce CO2. And it will produce methane or CH4 if oxygen is not present. So either one of those, we're putting carbon back into the atmosphere. Uptake and return of CO are not in balance. So we have this nifty up-down that happens every year, which is kind of neat. So what happens is in the spring and summer in the northern hemisphere, there are more forests in the northern hemisphere than the southern. So every spring and summer when you have plants, it's going to be absorbing more of that carbon dioxide. So then it takes a slight dip. And then in the fall and winter, there's less leaves to absorb. So then you're going to have a slight increase. But if you have looked over time, and even just over like your lifetime, guys, this is insane. Then if you go to my lifetime, I started back here. Look at that difference. That is insane. And it just keeps going higher. So we are having a problem with our CO2, and that is one of the common themes we will talk about this year as well. We now have the nitrogen cycle. So, and Somebody's lunch is over. So we have the nitrogen cycle, and we're going to do an activity in class with this, but there's lots of different places nitrogen can come from and go to between living things and non-living things. So check this picture out at some point. And then we have the phosphorus cycle as well. I want to make sure I'm giving you all the notes that are in here. Sulfur cycle as well. So I'd definitely be looking at these and the processes of how things are entering and leaving the environment. You don't need me to read to you. You can do that on your own. This we will be doing in class as well. So don't worry about this one. And then the practice questions, I'll go ahead and give you the answers for. So I would stop, pause. I would stop and pause and attempt those practice questions that are on questions 8 through 17 at the end of that note section. See what you can come up with from your knowledge, and then here are the answers. Oops. So see how well you did with those. There you go. If you have any questions, post them down at the bottom in the comment section or email me, and I will do my best to get back to you guys on that one. So before I leave, I want each and every one of you guys to know that you guys are good enough, you guys are smart enough, and that people like you. And if I don't see you, good afternoon, good evening, and good God, do your homework.